Hello students, welcome to mathematics classes. In this video we shall discuss chapter 2, that is polynomials, from your textbook. In particular, we will discuss exercise 2.1 and its related concepts. The very first thing that you need to learn from here is the zero of a polynomial. Now this is a concept which we have already covered in class 9. However, for revision purpose, let us cover some basic concepts here. So if I take a linear polynomial, let's say I'm taking a linear polynomial x minus 2. The question is, for what value of x this polynomial will become 0? The obvious answer here is 2, because if I put 2 in this polynomial, I'll have 2 minus 2, that is 0, isn't it? So what I can write from here, the summary is x equal to 2 is a 0 of the polynomial p of x, that is x minus 2. Let's take another example. Suppose we have a polynomial x square minus 9. This is a quadratic polynomial, isn't it? So now this is two zeros. One is 3, because if I put x equal to 3, 3 square minus 9 is of course 0. The other 0 is minus 3, because if I put minus 3, it will be minus 3 whole square minus 9, which is again 0. So the polynomial x square minus 9 has two zeros. One is plus 3, other is minus 3. In short, we can write them as plus minus 3. If we summarize, what is the 0 of a polynomial? The 0 of a polynomial is the value of x for which the polynomial becomes 0. This is a very simple concept. Now moving on, the next concept is graphical meaning of the 0 of a polynomial. The graphical meaning means obviously you have to deal with the graph. Let's take a linear polynomial again. Let's say I'm taking x minus 2. Let's say this is y equal to x minus 2. So x minus 2 is the polynomial. We have two variables, x and y. We are trying to draw the graph here. This we have already done in class 9. Now if I put x equal to 2, y will be 0. If I put, let's say, x equal to 4, y is again 2, isn't it? Now we shall draw the graph. What we'll do, we'll draw the coordinate system, y-axis, x-axis, and we'll plot the points. The first point is 2, 0, so this is the point here. Second point is 4, 2. Okay, the second point is here. And what we'll do now, we'll join them by straight line, and let's call it L. So what is that L? The L is nothing but the graph of the polynomial x minus 2. Now try to understand this concept. X minus 2 is linear, so it has degree 1, right? Now look at the graph L. At how many points L intersects the x-axis? Not the y-axis but the x-axis. You can notice the L has intersected x-axis here, and at particular this point the value of x is 2. So at how many points the graph intersects the x-axis? At 1 point. Let me put the summary here. The graph intersects the x-axis at 1 point. Now this one is important. Degree is 1 and it intersects the x-axis at 1 point. Because the degree is 1, it has obviously 1 zeros or 1 0, right? So there are three things: degree is 1, 0 is 1, and the graph intersects the x-axis at 1 point. Now let us try to expand this same concept into a quadratic polynomial. Now if I go to a quadratic polynomial, I will not get a straight line, rather I will get a curve. So I can get a curve something of this sort, right? Now interestingly, a quadratic polynomial has degree. How much degree is 2? So its graph should intersect the x-axis at 2 points. As you can see here, this graph has intersected the x-axis at 2 points. Till now it is very clear. Now here's the interesting part. We can also have the graph of a quadratic polynomial this way. The problem here is that the degree is 2. So it should intersect the graph, it should intersect the x-axis rather at 2 points. However, this particular graph has not intersected the x-axis at all. So it has intersected the x-axis at 0 points. Right? Now moving on. This is another case is possible rather. We can also have something like this where the graph intersects the x-axis at 1 point only. Here the degree is also 2. So as you can see, all the 3 cases, the degrees are 2, but we have 3 cases: 1 point, 0 point, and 2 points. Right? So here comes the concept. If we have a polynomial with degree n, then it will have maximum n zeros, not exactly n zeros, maximum n zeros, and obviously the graph will intersect which axis? X-axis at how many points? At maximum or at most n points. Alright, in the next slide this will be more clear. This is a summary. If we have a polynomial with degree n, then you're going to have at most n zeros, and the graph will intersect the x-axis at most n points. Let's take an example. Suppose I have a polynomial having degree 10. So how many zeros I'll have? Maximum 10 or at most 10. And how many points the graph will intersect the x-axis? At most 10 points. That is maximum 10 points. Now maximum 10 points means 0 to 10. All these values are possible, but it cannot be more than 10. I hope we are clear with this concept. Now based on this concept, we can solve exercise 2.1. I have taken 2 sample questions, others you can solve on your own. Now the question is, find the number of zeros for the following graphs. The graphs are given and you have to answer the number of zeros for the corresponding graphs. The concept is very simple. All you have to do is look at the graph and try to understand at how many points the graph intersects the x-axis. How many points? In the first case, 1, 2. Now please don't count this point because this is y-axis. You have to take this point, x-axis, and this points. So how many points? 4 points. So what will be the number of zeros then? Because the graph intersects at 4 points, the number of zeros will be also 4. The second graph, this one is very interesting. At how many points the graph intersects the x-axis? The answer is no points or 0 points. So the number of zeros in this case, will be also 0. If the graph intersects at 1 point, number of zeros is 1. If the graph intersects the x-axis at 4 points, number of zeros is 4. The concept goes like this. I hope you're clear with this one. Other questions are there from 2.1. You can easily solve them applying this concept. Now, based on this concept, I have provided some sample questions. The first one is, what is the degree of a constant polynomial? This you have learned in class 9. So let's take an example of a constant polynomial. Let's say 6. So some of you may be thinking, where is the variable? The variable is actually there. I can write it as 6 into 1. So 1 can be written as 6 into x to the power 0. So it can be written as 6 into x to the power 0. So what's the degree? The degree is 0. So the degree of a constant polynomial is always 0. Option B is the correct one. Next is a similar type of question. What is the degree of a 0 polynomial? The degree of a 0 polynomial. So first of all, what is a 0 polynomial? 0 polynomial. Your 0 polynomial is nothing but the polynomial, the constant polynomial 0, isn't it? So now how will you write 0 then? 0 can be written as 0 into x to the power 0. So by applying this logic, you will have degree 0. But there is a catch. 0 can also be written as 0 into x to the power 100. So degree is 100. 0 can also be written as 0 into x to the power 99. So degree is 99. As you can understand, by applying this logic, the degree can be anything. And because degree can be anything, it is not certain. The degree of a 0 polynomial is also not defined. The correct option is option D. I hope you have understood the logic here. Next one is a very simple question. What is the number of zeros of a polynomial having degree 5? Because the degree here is 5, number of zeros will be at most 5. The correct option is B. Next, the graph of a quadratic polynomial. Now this is interesting. I've already drawn out the graphs of quadratic polynomials. The graph of quadratic polynomial looks like this. This kind of shape is called the parabola. Okay, the correct option here is option C, parabola. Now I have provided a sample question for you people to try. So the question is, what's the number of zeros of x square plus 1? I'll give you a hint. So if we have x square minus 1, how many zeros are there? 1 and minus 1. So how many zeros? Answer is 2. Okay. Similarly, if the polynomial is x square plus 1, you have to tell me the number of zeros. Alright. Please try these questions, attempt that one, and please, if you can, then put a comment in the comment section. That's all. I have covered the entire exercise 2.1 and related concept in this particular video. In the next video, we shall be discussing exercise 2.2.